All right, so today we're going to be looking at our last form for quadratic functions, and that's going to be intercept forms. Okay, so we're going to be looking at that intercept form, and the most applicable way to use intercept form is when we're writing. Okay, and that's whenever you're given your solutions or your zeros and a point. Okay, so if we look at intercept form right here, this P and the Q, those represent your zeros. If I can write, there we go. So your zeros, your intercepts. Okay, we're talking about your x-intercepts. Your roots, which sometimes we call them, and we also call them your solutions. So all these things mean the same thing. So if ever you see one of those four options, okay, know that they all mean the same piece, okay? We also still have our a value, which has yet to change. My a value is still the same. And then we also have our coordinate points. So the x's are going to be the same x value, and our y's are going to be the y value. So all those pieces mean the same thing, or mean those labels. So if I gave you a point, you would plug in your x value for your x's and the y value for your y. So let's actually look at an example. So when we are writing, okay, if I give you your zeros or your solutions, okay, the first thing we want to do is label all of our pieces, just like we did with intercept or vertex form. Okay, so my zeros, we said were our p and our q. Okay, so this -3 is the p, and the 9 is the q. We don't care about the zero part because that should always be a zero. Okay, so we're never going to use that zero in this equation. And then our point is our x and our y. So now that we have those labeled, we're actually going to plug that into our intercept form, which is a x minus p and x minus q. Okay, so we're going to plug in all those pieces. Instead of a y, now we'll have this 13. So I'll have 13 is equal to, I still haven't given you an a value, so a. Our x value is the 10 minus my p, which was a -3. But what happens when we subtract a negative number? That's right, we're actually adding. So I can change that to a big plus sign. And then x minus my q, which was 9. Oh, not x. Silly Mrs. Mariani. That shouldn't be an x. We said our x value was a 10, so that should be 10 minus 9. All right, so we've labeled everything and we substituted everything in. Okay, so now we just have to solve for a. Just like when we were working with vertex form, we solved for a, so we have to solve for a here. So we can't simplify 13 equals a. 10 plus 13 gives me, or 10 plus 3 gives me 13. And then 10 minus 9 gives me 1. Now I'm going to multiply. So 13 equals a. 13 times 1 will give me 13. And then my very last step, the a and the 13 are being multiplied, so I'm going to divide out the 13. Those will cancel. 13 divided by 13 will give me 1 is equal to a. So my a value for this function is just a 1, which is great. So now we're going to substitute that a value back in, okay, with that p and the q value. So we still have a y is equal to, my a value is a 1, x minus a -3, so we can write that as plus 3. I'm going to get rid of that so it's not that messy. So plus 3, and then x minus 9. Okay, so notice that I still needed that p and the q value, and I need my a value. The x's and the y's stay the variables, the x's and the y's. We don't change those. All right. And that's really, it's very similar to what we did yesterday, only now we're using intercept form. So we're just plugging in some new variables. All right, so looking at number 1, it says write an equation in standard form to represent the following. Okay, so this one we're going to start with identifying our pieces. So yesterday we looked at, this was our h and our k, but today I want us to practice with using our zeros. So if I look at this, I have an x-intercept here because my y value is a 0, and I have one right here. So I can label those my p and the q, okay? And then I can just pick any point that I want to use for my x and my y. Well, I'm going to pick the easy one to use, which is 0 and 6. Okay, so now that I've labeled my pieces, I'm going to plug all of that into intercept form, which is a x minus p, x minus q. So instead of a y, now I'm going to have a 6 equals, I didn't give you an a value, so you can't pick that for an a value. Instead of an x, now we know that our x value is actually a 0, so that makes it pretty easy to work with. Then we have a minus our p value, which we said was a negative 3. But when we subtract a negative number, we're really just adding, so that becomes a plus 3. And then I'll still have my x value, which we still said was 0. So 0 minus my q, which was 1. And now we just need to simplify. Okay, so 6 is going to be equal to a. 0 plus 3 gives me 3. 0 minus 1 gives me negative 1. Now I have to multiply those together. So I'll have 6 is equal to a. 3 times negative 1 gives me negative 3. And then the very last step, I have to divide out that negative 3. 6 divided by negative 3 gives me negative 2 is equal to a. If you remember from yesterday when we did this problem, we also got our a value was negative 2. It's really just two options to do this. So from here, we're going to plug this back in. I actually think intercept form's a lot easier to work with. So now I've got y is equal to, my a value is negative 2, and then I have x plus 3 and x minus 1. Now, unfortunately, I can't stop there because my problem asks for standard form. Well, it would if there was an m right there, but standard form. Okay, so that means I still have to distribute this and simplify it. Okay, so I have to distribute that negative 2. So negative 2 times x will give me negative 2x. Negative 2 times 3 gives me minus 6. X minus 1. Then I have to distribute all of this together. So negative 2x times x will give me negative 2x squared. This is where you could also be using your box method if you wanted to. Negative 2x times negative 1 gives me plus 2x. Negative 6 times x gives me negative 6x. And negative 6 times negative 1 gives me plus 6. Now I just need to combine my like terms. And so I'll have negative 2x squared. 2 minus 6 will give me negative 4x plus 6. All right, go ahead and flip to the next page. So on this page, we're starting with a wonderful graph. And this one also asks for standard form because I'm just wonderful like that and I want you to write it in standard form. Okay, so we are still working with this P and the Q, and we're still going to be starting with our, well, that was a wonderful Y. There we go. We're still going to be starting with our intercept form, which is x minus P, x minus Q. Okay, so we're going to plug everything in. Okay, first we're going to identify our pieces. This first point over here is going to be the P, and this one over here is going to be the Q. If you flip-flop those, it does not matter. Okay, it doesn't matter which ones you pick. Okay, you're good to go. Okay, because you're going to multiply those together. So even if you flip the P and the Q, it's going to be the exact same thing. We also need our A value, and if I start on my vertex, I go over 1 and I only move up a half. That means my A value is 1/2. If I had moved up like 2 spots, then my A value would have been 2. If I'd gone down 1, my A value would have been negative 1. Okay, so you can kind of see how that's working. Since I'm only going up a 2, it's a positive 1/2, or up 1/2, it's a positive 1/2. So I'm going to plug in all those pieces, okay? So now since I already have my A value, I don't need the point anymore. So I have y is equal to 1/2 for my A value, x minus my P, which was a negative 3. So I'm really going to be adding 3. And then x minus 1. So I've asked for this in standard form. This is currently in vertex form. So I need to start by multiplying all my pieces together. I'm going to multiply the parentheses together first. That way I don't have to mess with the fraction. Okay, the less I have to work with the fraction, the better. And I know you guys feel the same way because very few of you actually like fractions like I do. So we're going to distribute that x first. and then the 3. So that 1/2 is just going to hang out front. X times x will give me x squared. X times -1 gives me negative x. 3 times x will give me plus 3x. And then 3 times -1 gives me -3. From here, I just need to combine my like terms. So I'll have y is equal to, that 1/2 is still just hanging out front, x squared. Negative x plus 3 gives me plus 2x minus 3. Then my very last step, I'm going to distribute that 1/2. And I'll have y is equal to 1/2 times x squared gives me 1/2 x squared. 1/2 times 2, well, half of 2 is just plus 1x. And then half of a -3 gives me -1.5 or 1.5. That's going to be my final answer in a nice standard form. All right, if you have questions on that, just let me know. The next one, number 3, says a squirrel jumps from a branch to another branch and has a max height of 4 inches after going a horizontal distance of 3 inches. Write a quadratic function in vertex form. Ooh, we're switching back to vertex form, guys. That models the jump path, assuming the squirrel jumps from 0, 1. So we're going to start with a little picture. Here's my squirrel. I can't draw a squirrel. There you go. It looks more like a cat. But anyway, there's my squirrel. And he jumps from a branch to another branch. He starts at the point 0, 1. Okay. And then he has a max height of 4 inches. Okay. And that's after going a horizontal distance of 3 inches. This was the smallest jump a squirrel has ever made in its life. So that means that we know its vertex is going to be this point right here, which is 3, 4. Now, since we have the H and the K and the X and the Y, we can go ahead and start labeling stuff. This is going to be my H and my K. Whoops. Okay, so this is my H and my K. This is my X and my Y. Okay, so now I can plug everything into my vertex form. So y is equal to a, x minus h squared plus k. So we're just practicing both forms because I know sometimes we need a little bit of a reminder. My y we set down here was 1 equals my a value I don't know yet. My x was 0 minus my h, which was 3, squared, plus my k, which is a 4. So then we're just going to simplify this because we got to get our a by itself. So 1 is equal to a. 0 minus 3 gives me -3 squared plus 4. We have to deal with that wonderful exponent. So I'll have y is equal to a. -3 squared gives me 9 plus 4. We're still solving for the a value, so we subtract the 4 from both sides. That goes away. 1 minus 4 gives me -3 is equal to a times 9. Now we need to divide out the 9. -3 divided by 9 reduces to -1/3. So my a value is going to be equal to -1/3. So I didn't just ask for my a value though. I asked for the vertex form. So I'll have y is equal to -1/3. And then x minus my h, which was 3 squared, plus my k, which was 4. And the last little bit of this problem says state the y-intercept and explain what it represents. My y-intercept is up here. So it's 0, 1. Remember, when we state the y-intercept, it has to be a point because I'm picky about that. If it's a y-intercept, it is a coordinate point. And what does it represent? It represents the squirrel. That's not how you spell squirrel. Wow, that's a struggle. Started 1 inch off the ground. All right. Now, looking at the very last one, a little bit of review over our transformations. It says sort the quadratic functions from narrowest to widest. Okay, narrowest means it's going to be a number where the a value, the absolute value of the a value is greater than 1. Okay, so the bigger number, the narrower it is. So the largest number we have for our a value is 8. So a is going to be the narrowest. The next one that we have, really the only one without a fraction, is 1 or -1. So our b value is going to be the next narrowest. Now, when we're talking about the widest, we want a values where the absolute value is less than 1. So we want fractions and decimals for those. Okay, so the larger fraction of the two is the 2/3. So it's going to be c. And then the smallest fraction is going to be d. That means it's the widest because it's the smallest fraction. I didn't mean for those to go in order, but that's just nice how that happens sometimes. All right, if you have any questions about this stuff, let me know. If not, you can move on to your homework.